Go ahead and start the recording. Sonita, you wanted to say something?
I wanted to say I actually began watching it, but then I really had great issues with connection.
Okay.
If not, it was really encouraging. So today, probably when I step out, I'll try watching it while I'm still at work because where I am
Oh,
right now, there's serious connection issues.
okay. Quite understanding. Yeah. Maybe others can then find time as well. It's if you are looking for motivation, inspiration, that video on AWS Cloud Services is one for you. All right. Enough of talking. Let's see where we can start today.
Good morning.
All right. So I'll just appeal that if you, yeah, welcome everyone. Hey, morning, yeah, yeah. Well, for those who, if you are not talking, just be on mute. Just that we ensure that the class is there is no interferences as we go along. All right. Um, so today, let's start with the introduction to cloud. And before I go ahead, I will just, we did talk about, I did play the video of what cloud is yesterday. I hope you had time to look into that. So today, yeah, I'll still just give that and then go a little bit deeper. But before I move to that, I would just want to point out that we did talk about cloud, but this is what you come to realize that the cloud is all about. You, or one way in which you can interact with what is called the cloud. So you're able to create an account, and AWS provides a free tier for most people for 1 year, and you can join in and be able to do lots of yeah, carry on most of the tasks that you can do for free. Or let's say the basic ones, they call it the free tier, which you can use it for practicing for free. We'll go ahead at some point and help, uh, let's say just try to assist on how that is done. Just a moment. Mm, okay, just a moment. So, right, okay. Just a moment, I wanted to update something. Yeah, right. So when you have your account, when you sign in, you'll be able to come up, you're able to have access using the AWS Management Console. You're able to have access to all AWS services, and one of them is the EC2 Elastic Compute. Um, which you have here, you're able to build web applications. So I just wanted to bring this so that you see as we go along, we'll try to do some practice sessions so that you have hands-on. You'll be encouraged to create your own account as well, and then do hands-on, because if you really want to succeed in this field, having some hands-on and working with the console in order to deploy services is what makes the difference. And these are all the services or that you have with AWS at the moment. You see they start from compute, storage, databases. Companies move to cloud. Maybe they need storage, maybe they need compute services. You come to realize that EC2 is a virtual server, which is just a representation of a physical server. And then databases, I'm sure along the line you've heard about databases. So this is so much here at the moment. Don't be intimidated by it. As I always say, if you can think logically, you'll be able to handle this. So let's go back to the lecture of today. The objectives is to understand the benefits of cloud computing, characteristics of cloud computing. We'll talk about cloud computing and traditional IT, the types of cloud computing, the deployment models, and we'll talk about the deployment models before coming to the types, then examples of cloud computing, then a brief on the pricing model, and then yeah, overview of Amazon Web Services. So by the time we finish this, you will have had that grasp. Cloud computing is the on-demand delivery of IT resources over the internet with pay-as-you-go pricing. You did notice I went to the browser and I could show you all the services. One way to access what you call AWS Cloud. So I have the delivery of all those IT resources over the internet. All I need is an internet and a console, and I'm able to access those resources. Afoni, you raise your hand up, Terence. Any question?
Yes, it's like somebody is saying in the browser that they cannot see your screen.
What about every other person? Can every other
But I
person
can
see?
I can see your screen from here.
Um, please, maybe you need to check at your end. That is Sonita. Please check at your end. I think if you can, I think if everyone is seeing, then maybe it's at your end then. Yeah. Okay, instead of buying, owning, and maintaining physical data centers and servers, you can access technology services such as computing power, storage, and databases on an as needed basis from a cloud provider like Amazon Web Services. Yeah, Amazon Web Services is just one of the public providers. You have Google, you have Azure, and then those are the three main hyperscalers as they are referred to. Then you have yeah, Oracle, IBM, those are others that are really coming up. Let's talk about characteristics of cloud computing. What makes a service, or what are the characteristics that will make you be able to call particular service cloud computing? So these are just very key characteristics that you should know. So the very first thing is on-demand self-service. On-demand self-service, a consumer can unilaterally provision computing capabilities such as server time and network storage as needed automatically without requiring human interaction with each service provider. What this means is I can go to the console, I can say I need a particular database that's computing capability, or I need a certain storage, and it will be automatically provisioned for me. I won't have to wait for someone to do that manually. I won't have to send a ticket to AWS and then someone go and do that. So all of that happens automatically, and I think we'll do that before the end of today. Broad network access. So capabilities are available over the network. As you see, I did show the management console, so I can be able to access those capabilities over the network through standard mechanisms that promote use of heterogeneous thick or thin cloud platforms. So if I'm using here, we are referring to platforms here are mobile phones, tablets, laptops, and workstations. Resource pooling, the provider's computing resources are pooled to serve multiple consumers using a multi-tenant model. We'll define what multi-tenant model is as we go along, with different physical and virtual resources dynamically assigned and reassigned according to consumer design, the consumer demand. So there are resources that are in a pool and you have multiple customers just having access, able to access that, um, and that's going happening in a kind of dynamically fashion. So those are some of the key three. The other four, the fourth one is rapid elasticity. Capabilities can be elastically provisioned and released, in some cases automatically to scale rapidly outward and inward consumer rate with demand. To the consumer, the capabilities available for provisioning often appear to be unlimited and can be appropriated in any quantity at any time. So here with cloud computing, what happens is a customer can decide that, or maybe for some reason they need just one, say one virtual server because maybe imagine a web server or someone operating a website and he's having less traffic, then maybe he happens to have just one EC2 instance running. But what happens if, let's say, during the sales period when many people are buying a lot, like many people we do during certain parts of the during certain periods of the year, and then that web server for some reasons cannot be able to meet up to demand. So it will scale. You will need to have more, say two or three. This happen very rapidly, so it can rapidly. There's some sort of elasticity. You can rapidly have many of them, so you can have two, three, four instances. And if immediately after that sales period you no longer need them, it can stay scale back inward, and then that happens in a fashion that is kind of automatic, and that's what is referred to here as rapid elasticity. Then measured service, cloud systems automatically control and optimize resources used by leveraging a metering capability at some level of abstraction appropriate to the type of service. So resources usage can be monitored, controlled, and reported, providing transparency for both the provider and consumer of the utilized service. So what happens is, yeah, it's a measured service because you pay for what you consume. But this happens the reporting is in a very transparent manner for everyone. So well, there are fixed prices, and when what you consume at the end of the month, let's say you have to pay for that bill, is measured in a way that everyone sees the transparency in it. That's just what is referring to here, the measured service. So those are the capable characteristics of cloud computing. And then, yeah, what are the benefits? What with all of that? What are the benefits that comes with cloud computing? Some of them list fall in on that those characteristics, but there's what is referred to as agility. The cloud gives you easy access to a broad range of technologies so that you can innovate faster. So what happens with cloud computing is it offers a kind of a new horizon for customers and users, broad range of technologies. You can easily spin up resources and from just from sitting being connected, say from one of the different mechanisms, one of them being the management console, so you can quickly spin up resources. We have talked about elasticity. You can either increase more or reduce them. So those are the benefits that come with cloud computing. Cost savings, the cloud allows you to trade capital expense for variable expense and only pay for IT as you consume it. So you only pay for what you consume. The variable expenses are always much lower than what you will pay it for yourself because of economics of scale. Imagine a situation where most what a business will normally do is they will buy, let's say, all the servers that they will need and then try to deploy the resources. And what always happens is they are not using all that is available. Like, they may buy lots of servers. The example could still be that of, let's say, if at the beginning of the year or mid during the year, they have about 10 servers because they think that is enough. What happens is when the sales periods come, they will then, and there's high traffic, they will realize that they don't have enough capability, enough computing resources, and then they are not able to deliver. And to go and buy another server to come and configure it and get it ready, it takes a lot of time. So that, but but if, let's say, even at the mid of the year they decide to buy so much because they know there will be sales periods, what happens is then there's wastage. So the compute capability that they are not using, there's wastage, and then yes, unnecessary expenditure. But with the cloud, there's a lot of flexibility. You can be able to to always have cost savings comes because we are able to provision just what you need and then move up or scale down when necessary. You deploy globally in minutes. The cloud is a global infrastructure that that is almost and then what happens is rather than deploying, say, just around where you are, like in the traditional centers. The possibility is you have the cloud. With the cloud, you have different you can have like AWS, they have different regions, and these regions is the AWS network has data centers placed in different regions in the world, and you can deploy your compute or your resources in these different regions. So even if you are sitting in Europe, or you are sitting in America, you can deploy in Asia, you can deploy right back in Africa, also, or South America. And that's one thing about the benefits of using the cloud. Any questions so far on what we've discussed about the characteristics and the benefits? That's literature to understand and have a good grasp of what that is. Okay, let's talk about cloud computing and traditional IT. Traditional, one thing is resilience with an elasticity. I already started discussing that in the examples I was giving. Information and applications hosted in the cloud are evenly distributed across all the servers. If one server fails, no data is lost and downtime is avoided. That's um, because with cloud computing, I think that's just something to take. Information applications are distributed across all the servers. This is different from the traditional model where maybe one server going down, it becomes a big difficulty for the IT team to help on that. Better computing power, this means your software and applications will perform faster. AWS is hosted by a very big company. They have all the compute power that you can imagine of. And this will not happen if you were, let's say, a small business and you needed, let's say, some sort of compute power. It could be very expensive, but with AWS as a public provider offering this compute power, you can then use it as the fee is not very expensive. So you can use it. Say maybe you needed to do some sort of machine learning models. You can then pay a small fee and maybe do your models for this month, and then you are fine. But if you are just like, if you are supposed to, let's say, buy all those resources as an IT um, department of a company, that could have been very expensive and maybe not possible. So there's better computing power in the cloud because you have access to all the computing power that's available. Austin, you have your hand up. Go ahead, please.
Yeah, hi, Ben. Just clarification, as you said that the applications are evenly distributed. So despite the region setup of the servers, so what you're saying is that the applications are hosted across all the regions in, I mean, despite the, what I can say, regionalization of the servers, but the applications will still be hosted over all the regions. Is that understanding correct?
Yes, that is one way to look at that. If you were to have an application that is there are some services that are regional. So yeah, so for those services, they will be across all those regions. A service like I am, which is used for identity and access management, you can have access to that across all regions in a way that you feel like just is in one region. If you deploy an application, because you have regions and then you also have zones, right? We'll come to those definitions. So you can also have a load balancer sitting in front of, let's say you are hosting a web application and then that is in different zones. Those zones are also another geographical segmentation, say, of a region. So you can have a load balancer sitting in front, and it will have the application will be hosted on different web servers that are located in different zones and distributed evenly. So yeah, so that is what you were saying there is absolutely correct. But you have more understanding of that when as we go along and as we discuss different capabilities as well. Yeah,
Okay, thank you.
great. Um, Traditional IT systems are not so resilient and cannot guarantee a consistent high level of server performance. Yeah, that is when you having, because before cloud computing, if you notice most, like you have a bank before used to have a whole IT department that was maintaining, let's say, their data centers. But what happens is they don't guarantee consistently and high level of server performance compared to the cloud, where you have a kind of yeah, that consistency is guaranteed. Flexibility and scalability. Cloud hosting offers an enhanced level of flexibility and scalability in comparison to traditional data centers. The on-demand virtual space of cloud computing has unlimited storage space and more server resources. You have full control to install any software as and when you need to. This provides more flexibility for your business to grow. Just yeah, flexible. So when you are using the cloud, the on-demand aspect of it gives you so much flexibility. And yeah, the other aspect of cloud computing is this unlimited storage. You come to know about different types of storage. One that is very popular, and I think one of the main service that AWS had right back, I don't know whether it's 2007 or it's S3, which is an unlimited storage. Yeah, and you'll come to know more about that as we go. But when you're hosting, when you have your applications running at your own data center, you definitely have a certain limit of how much space you can have. And traditional IT infrastructure can only use the resources that are already available to you. If you run out of storage space, the only solution is to purchase or rent another server. That is the lack of flexibility with traditional data centers. When you, yeah, the resources you have, that is, it's finite. I'm still coming back to that aspect that the traditional data centers, you can see that it's finite depending on the resources and the storage they have. Once they need more, they need to go out and buy. But when you are dealing with the cloud, you just have instead more, you can use as much as you can. It just depends on you. There is always going to be enough, at least. Not saying that yeah, if you need more, there is a certain limit definitely that you have on your accounts, but if you need more, that is when you can always reach out to AWS that you need more. And there's a reason for that, just to avoid maybe certain mistakes or certain over provisioning that customers can do. So when you sign in for your AWS account, there's always a certain limit on compute or maybe, but something like storage is unlimited. And you realize that maybe if you are launching resources in a particular region, there may be a certain limit. But if you need more, you can always then request. But the limit that is always offered is always almost enough to handle most of the common workloads that you have. So yeah, so that's some of the differences. Another one is here is automation. The key difference between cloud computing and traditional IT infrastructure is how they are managed. Cloud hosting is managed by the storage provider who takes care of all the necessary hardware, ensures security measures are in place, and keeps it running smoothly. With cloud computing, you don't, yeah, you are not bothered about the hosting. You are more interested in using the services. So like I did show on the screen, you have the possibility to access the cloud services through the console. That's all I'm worried about. I just need that to be up all the time. But but in the traditional IT, you have to ensure that you are managing um, the data center, where the server stored, the heating and the cooling of those data centers. You have to ensure the cabling, you have to ensure lots of things. So when you have traditional data centers, as it shows on the next point, it require heavy administration in-house, which can be costly and time consuming for your business. So instead of doing what you need for your business, you end up carrying other tasks that were not very important, that doesn't focus on your business. With cloud computing, the focus is more on your business. You don't bother about how the servers are hosted. You don't bother about the heating or the cooling. AWS will take care of that. And we'll be talking more of those things under shared responsibility as we go along.
I
Running costs.
have a question.
Yes, go ahead, Chakun.
On most of these comments, it often sounds like with the cloud, there is almost no need for an IT department, but you still need an IT department to an extent, right? But then the question is, how much of the cost do you save by just reducing the IT department and the infrastructure?
Right. Right, you're right. There is just that the skill sets, the skills required by the IT department change, right? So what you need now is the traditional IT department is replaced by people who understand and know how to use the cloud, rather than those who understand and are running and managing the traditional data centers. So you definitely still need, because if a bank needs to, let's say, deploy services online, they will still need the IT department that have those skills on how, when I say on the cloud, not online, they will need an IT department that have those skills on how to work with the cloud. So the skills change, the skill sets change. Is that's what you were looking mentioning, right, Joachim? Just to be sure.
That's right.
Yeah, yeah. So the IT department is still there, but it's just that the skills sets now change. Um, Mark, I noticed you have your hand up.
Yes, Mr. Ban. I was just wondering, with traditional IT infrastructure, for example, you are sure and you are sure that you own your server. Why with cloud computing, somebody owns the server? Let me put it that way. It's manipulated by somebody. How far
Mhm.
are you sure your information is safe? How far are you sure your information cannot be manipulated?
Absolutely. That is the question that came up early on before companies started adopting the cloud. Many didn't want the cloud because of security reasons. That was a very big issue, and no one was talking about the cloud. But even though AWS started right back 2006, I hope I'm right there, but companies really, it really became something fashionable maybe around 2014, 15. And now everyone is moving to the cloud because there is a lot of transparency. What happens is for every cloud provider, they meet up to particular standards that are governed by third parties to show that they are meeting to certain security, to show that the services they are offering, are not, let me use the word you are saying, again, they cannot tamper with the data of customers. But even with all those assurances, there are still some companies that still prefer to have their own data centers, which is when you end up with what we call hybrid situations, where you have a company that maybe if there are some applications that are very sensitive to them, they will prefer to still run it on their own traditional IT. And then the ones that they are comfortable to run on the cloud, they will do so. But there's a lot of documentation on different standards that all cloud providers have to meet with, that is governed by third parties, and they are audited, so to say, all the time to ensure that they are meeting with those standards. Yeah. So the question of security, and if you really want to have your data, because one way of ensuring that your data is not handled is by doing what you call encryption. And if you encrypt your data and someone doesn't have that key, you will not be able to, even AWS, even if it's stored at their end, they won't be able to access it. But that was one thing that will come about when we start talking about security. Yeah. But cloud, but it's been really better, and yeah, that fear is almost gone. That's why we have many customers now using the cloud. Mark, hope that did help.
Yes, it's well understood. Now,
Yeah.
how will AWS, how will they benefit from, if when I'm using their services, how do they benefit?
Right, you pay per month. You pay. There's a cost. Of course, they are not offered for free, so there's a cost that come to it, which is where they yeah, make money. Then it's just that it's cheaper for you, but then because AWS as a public provider, they have many people using it. So having many people using it, they end up making money. Even though when you look from your end, it's like there's a reduced cost than if you are running your own data center on your own, or yeah, on your own, right? They do make money from it. Yeah,
Thank you.
great. You're welcome. Chabanjong, please go ahead. Your hand is up, but I see your audio is
Yes.
not activated. Yeah, go ahead. Okay, since you're running different, go ahead. Chabanjong. Okay, right. Um,
Getting me.
yeah, please try again. Let's see if we can hear you.
I am actually using another device. I don't know if you are getting me.
I can hear you now.
Okay. Actually, I have two questions. When we talk about cloud computing, in areas where do they have their own network system? For instance, if I'm somewhere where we do not have the internet, uh, does it function there? Can a company situated in, say, somewhere deep in Cameroon where you don't have network access, they have the possibility of using this system or cloud computing? Secondly, does the client have access to already stored data even after their subscription is ended?
It's ended.
Yes.
Okay. The first question is, if you did notice on the characteristics, it did state of on-demand IT resources over the internet. So one of the key characteristics you're able to access cloud services is um, to have internet. So without internet, it's not possible because AWS, to access it, you have to go through you have to go through the internet to access that. Except maybe you have a direct connection. That means if you have at your telecommunications company, you are able to have one that will be able to ensure that they have a cable that moves from your company and maybe goes to the next data center where it meets AWS. Then you can have that access without the internet, which will be very costly. But traditionally, you can have that over the internet. So that's the first thing. You can have those two choices. The internet is essential, or the alternative will be having a direct connect, which will be very expensive, but it's possible. Yeah. We'll learn about all those options as we go along. And then, yeah, the other question is, sorry, can you repeat that,
Yeah.
Chabanjo?
Yeah. The other
If
question is,
okay, if your subscription is over, right? If you still have access to your data,
yes, that's
um,
correct.
right. I don't know what you mean by if your subscription is over. If you are using, let's say, if you stop using the cloud, the only thing you can do is better to take your data out, because if you pay for what you use. So if you are using, let's say, S3 bucket, then every month you get a bill for the usage. Every month you get a bill for the usage. So if you stop paying, that means yeah, maybe then you have a bill that is unpaid. I don't know what happens, what AWS will do if you don't pay their bills. Maybe they can then cancel you, or I have never thought of that. But if you don't pay your bills, you are not paying for the resources they are using. So if you no longer want to use AWS, I think the best option would be to get your data out and then you don't need to pay. If not, you'll be receiving a bill. And if you don't pay your bills, I'm not so certain what AWS will do with that.
Okay,
You
thank
still
you.
have to look down. You're welcome. Yeah, Bruno, you want to add something before we go ahead? That's fine. Or you want to have a question?
Yes, Mr. Ban. Yeah, I wanted to add something in relation to the question that was asked earlier on how AWS makes money, right? And I just wanted to give a simple analogy of think of AWS as a rental property, right? So they come along and propose a solution for you. So instead of saving, for example, $10 million or 10 million francs to build yourself a house, I'm going to rent your house and provide all these amenities for you. I'm going to provide security. I'm going to provide you maybe a bigger or better house to live in. Um, I'm going to give you all the utilities, and all you need to do is pay a fraction of what you would spend or you would go spend building yourself a house. And all I require is for a small token every month, and you're good to stay in this house for as long as you want to, right? So the same thing goes with AWS or any cloud provider, Azure, Google. They propose a solution for you instead of spending a lot of millions of dollars building a data center, renting, uh, or buying servers, buying computers, network gears. We're going to provide all that for you. All you need to do is send your data over, and we're going to store it for you. So you don't need to worry about all the hardware or the physical hardwares. To an extent, of course, it depends on what solution you pick, because they do offer a bunch of them. So that is a simple analogy of if you want to relate with what AWS does, or how they make money.
Great. Thank you for that. Christabel, you have a question or something you want to say? Okay,
Yeah, I have a question.
go
My
ahead.
question is still on security. The AWS service, is it affiliated with the government?
No, it's not.
Okay, if it's not affiliated with the government, how far am I sure that they are not going to, because most companies, they always have two books. When it comes to taxation, what makes a company to use AWS services? What assures that company that they are not going to share their information with the government?
Okay, I get what you're saying. Okay, what I get what you're saying, like, okay, you may have your data on AWS and you don't know whether they will share that information with the government if you didn't want them to do that. Is that what?
Yeah, yeah.
Okay. Now that's a difficult one because and that's why some companies, or you see it, some countries, they will insist that if that even though they are using the cloud, but if they are going to use it, the data centers should be in the government or in the countries where they are located. So that is a, yeah, they are compliant. Those are those, yeah, and it's true. Governments at times abuse that, and let's say if they know, if for some reasons they will want to have information about a particular company and they know that it's using AWS, then maybe for compliance reasons, maybe AWS by law will have to hand that information if necessary. But those are legal issues that honestly with you, I don't know how it works, but I know that that can happen where maybe a typical, I know America is typical of bullying companies. So they can bully AWS, for example, to hand information of a particular company, if or if particular personality, if they needed to. So those are very, those are very legal issues that, yeah, we can't dig into and we can't say what is what. But AWS is as it stands, is a private public company. It's not run by any government. Yeah, but they have to operate under laws of particular countries as well. Yeah.
Thank you.
Yeah, you wanted to add something before we go?
Yeah, sure. I just wanted to add that in addition to what you said, Uncle Banjika, there are also some AWS services that once you use, like for encryption that you mentioned earlier, once the customer use like maybe encryption from the customer side before storing your data maybe in a S3 bucket, that's where you store some specific type of data. So before you store the data there, the data is encrypted. So even if AWS have access to it, or even if at some point the government wants it, so it boils down to you, the customer, if you want to give, because even the government takes that data, it's like they can't read the data. It's just written in some type of some that it makes no sense. So even if they read it, and there are also some devices, as the course is going on, you get to know those devices where if AWS itself tries to sign in, log in, like Cloud HSM, tries to log in those devices without your password at some point, maybe from 3 times, and they log in the device and it's not the right password, then immediately all the data gets lost in the device, deleted by itself, or the device. Yeah. So just to add to that, and with other security services, it makes it impossible for your data to be seen by AWS if they want to, in case.
Thank you for that addition, Yoyo. Yeah, so there are different mechanisms where if you want to go that extra mile to have your data encrypted and you are the only one that have access, there are. So people who really want that, there's a possibilities. Thanks for you bringing that up. Let's leave the questions and comments for now and try to go through the material, Renee, if you wouldn't mind. You can ask your question on chat. And for others who have comments, let's try to cover what we can and then come back to questions again later and clarify most of that. Um, I was on, yes, I think we did talk about in-house management. We're talking about, it's because if we did talk about, yeah, pay for what you use. You will need to, cloud computing versus traditional IT. You will need to purchase equipment and uh, just mute yourself if someone had noise there. Okay. Okay. You will need to purchase equipment and additional server space upfront to adapt to business growth. If this slows, you end up paying for resources you don't use. This is talking about the running costs between cloud computing and traditional IT. Talking about security, which is a question that many, it seems to, yeah, many of you have this morning. Cloud computing is an external form of data storage and software delivery, which can make it seem less secure than local data hosting. Choosing a cloud service provider that is completely transparent in its hosting of cloud platforms and ensures optimum security measures are in place is crucial when transitioning to the cloud. With traditional IT infrastructure, you are responsible for the protection of your data, and it's easier to ensure that only approved personnel can access stored applications and data, which is what many of you did mention. A significant amount of time and money is needed to ensure the right security strategies are implemented and data recovery systems are in place, which can also be very, very which can also be very, very demanding, because even though you may be trying to do all everything in-house on your data center, having the right personnel and the qualified one that can do that all the time can be very, very challenging. But with the cloud, there are many, many options. So on the aspect of security, you learn some of them in this course that you will see that of interest. You did mention one already, using Cloud HSM, you come across KMS. So it's going to be exciting, just hang on. Advantages of cloud computing. We've been talking about some of that. You trade capital expense for variable expense. What this means is instead of having to invest heavily on data centers, the example that Bruno was giving, you know how you're going to use them. You can pay only when you consume computing resources and pay only for how much you consume. So rather than really spending so much at the beginning, you go for the variable expenses, paying for what you use. Benefit from massive economics of scale. By using cloud computing, you can achieve a lower variable cost than you can get on your own because usage from hundreds of thousands of customers is aggregated in the cloud. Providers are is aggregated in the cloud. Providers such as AWS can achieve higher economics of scale, which translates into lower pay as you go price. So yeah, these are some of the concepts, especially some of you maybe who are definitely, I hope everyone here is thinking of the exams. Some of the literature that we're looking here is a very fundamental. You need to remember and really understand what those like what is because you'll be surprised, you may be surprised that some of it is what comes up in the exam. So make sure that you're having an understanding of what this is. If you cannot understand it now, just yeah, review them again. Just logical thinking, as I always put it, you'll be able to get it. Stop guessing about capacity. We already talked about that. That's one of the advantages about cloud. You don't when you are operating in data in a traditional IT model, what always happen is you don't know how much capacity you need. But with cloud, there is so much automation that you don't, if you need 10 servers with this, we did talk about agility. With just a split of a second, you have 10 servers that are ready for you. If you no longer need those 10 servers and you need just 3 or 4, you have the others ones are automatically, scaled in and they are taken off and you have just that. And that happens at a very fast rate that you need. So you don't guess about, but in the traditional model, should you buy 10 servers and what happens if you no longer need those 10 servers? Who is going to remove them? How are you going to resell them? So you have so many things that comes into place and you end up spending so much or you don't have the enough capability to deliver as you would like. Increase speed and agility. We did talk about that. The speed um, in which in which software is deployed these days is so high because of the cloud. That's why we have so many changes all the time. The cloud has come and made a lot of changes in the way software is being delivered. Stop spending money running and maintaining data centers. So you don't really, you focus on the projects that differentiate your business, not infrastructure. Cloud computing lets you focus on your own customers rather than on the heavy lifting of racking, stacking, and powering of servers. A bank is supposed to be offering banking services. When they following the traditional model, when a bank has an IT department, before they realize they are into managing data centers, which is almost everything that happens with almost every company when they were operating under the traditional IT model, because every company had their own data centers. And because of that, they were dealing with how do we manage and run these data centers when it's not really their focus of their business. But with the cloud, they no longer bother about all of that. Their focus is delivering the services that they are supposed to deliver. You go globally in minutes, so applications in multiple regions around the world with just a few clicks, and it's really low latency because if you are sitting in Europe and you deploy an application and you want to deploy an application, you can deploy it. If you know that your customers are in Europe, you deploy it in the region in Europe that is closer to them. If you know that your customers are in Asia, then you deploy it in a data center or in a region. You come to know that these regions only have data centers at the back end. You deploy in that region that is closer to Asia, which means that your customers, is what is called latency, a very important factor for applications, and they will be able to access them much more better, faster. So those are the advantages that come with cloud computing. And as I say, take your time to know these advantages, understand what agility is, understand what elasticity is, capital expense for variable expense. What does that mean? Don't just have the key highlights. Take some time and read and think about them. Because as I say, the fundamentals of of cloud computing ensure that you have a good understanding of this, like the characteristics of cloud computing. When you say on-demand self-service, what does that mean? When you say resource pooling, what does that mean? So I encourage you, if you've not been able to grasp this now, the PDF file will always be shared, as you know, and of course the recording, you can listen, you can read that, and you can also play back and see how far you can go. Let me talk about deployment models of the cloud. You have what is called private cloud, the public cloud, and the hybrid cloud. We've mentioned that the private cloud is the situation where you still have some companies, maybe for very strong reasons, they still insist they want to have their data centers. But now their data centers is actually the infrastructure operates and meets the characteristics of what we did talk about, the characteristics of cloud computing. If you are able to have infrastructure that satisfy all those characteristics, then that's a cloud. So you still have some companies that mean to have private cloud. That is just a cloud services used by a single organization, not exposed to the public. The public cloud is cloud resources owned and operated by a third-party cloud service provider delivered over the internet. So AWS is an example of a public cloud. You have Google Cloud, you have Azure. Those are all examples of of public cloud because they offer it over the internet, and you use and you pay. There's the hybrid cloud, which keeps some servers on premises and extends some capabilities to the cloud. So hybrid is just a mixture of both worlds, the private cloud and the public cloud. You still have organizations, like I said, for some reason, they may want to operate a private cloud, maybe for some, it could be for regulations or compliance reasons, it has to run on private cloud. So they have applications that will be running, but then there are other applications they will want them to run on the public cloud. So they end up using the private and the public cloud, and that's referred to as hybrid cloud. Okay, let's go to, I was expecting just a moment here. Do I have that? Just a moment. Okay. Let me go to the next one, but just I check something just to be sure that I have. I have that here. I wanted to bring up. Okay, yeah, I have that. That's fine. Just wanted to be sure I have the link for that. Okay, we've talked about private, public, and hybrid cloud. Then there are different types of cloud computing. The only way yeah, you understand this when, actually, sure. Let me see if I should go to the diagram first. Let me come here first and then come back to the diagram. So this is what's called on-premises. On-premises is like, like I will take an example again of a bank that have their own data center running. That's what is referred to as on-premises. So they are managing from the network, storage, servers, virtualization, operating system, middleware, runtime, data, and applications. These are different characteristics or features when you are running applications. So they need all software and applications. They will need maybe a network, a storage. So all of this is managed by you. That's what is referred when a company have the infrastructure and is managing all of it, and runs all of it, they manage all of that. What we have here in blue is managed entirely by that organization. When you start using the public cloud, there is a certain level of there are certain things that you no longer manage because there is some, like I said, I showed on the console you can go there and then just, let's say if you needed an EC2 instance, which is an example of a virtual machine, which you can think of as a physical representation, a logical representation of a server. If I need that, I'll go and fire and it comes up. But the question is, what about the network and the storage and the servers? That is, where is it running? Because once you do that, before you have a server, it normally needs some sort of storage. But you no longer manage that. That kind of segregation, or when you reach this level where part of the infrastructure is no longer managed by you, it gives rise of different types of computing, depending on what part, at what level you can manage the infrastructure, and then the other part that is managed by AWS. So let's look at this. So this gives rise to different types of computing, of cloud computing, and the first one is here is known as infrastructure as a service. That's why I have it IaaA. If you look here, we have that here, infrastructure as a service. And what basically this means is it abstracts away the physical compute, network storage, and the technology needed to virtualize those resources. We'll talk about virtualization in our next class, and you'll be able to understand this very well. I'll try to ensure you see, let's say normally you have your laptop, and then I'll give that example, but we'll look into, because I know just saying this, maybe for some of you, it may sound so complex, but don't let this, do not allow this to intimidate you. So what we'll have is infrastructure as a service extracts away the physical compute, network storage, and the technology needed to virtualize your resources. So you don't bother about that. You just use the virtual machine, like in this case, if it was a virtual machine. So IaaS is commonly used for development and test environments, customer-facing websites, web applications, data storage, analytics, data warehouse workloads, and backup and recovery. When you learn about each type of cloud computing, always try to figure out and understand what it's used for. In the early beginning, this may also be difficult to understand because some of these terms are new, but as we go along, as you read and come back to the literature, you start seeing how applicable this is. Platform as a service, it's this one. If you notice here, when we did talk about infrastructure as a service, the network, the storage, the servers, and virtualization is abstracted away from you and is managed here. If you notice on this diagram, the yellow stand by managed by others. So in the beginning, when you have the on-premises, you manage everything from networking to applications because you own the infrastructure. With AWS, part of the infrastructure is owned by AWS, and AWS can allow you manage it's up to the operating system to the OS layer. But then the other part here is managed by them. But there's also what is referred to as platform as a service, where AWS manage right up to the runtime environment, and then you only bother about the applications and the data itself. What this means is that it makes it very easy for you to maybe deploy your applications. You don't need to, because the more when you manage more of the infrastructure, it means you need more time for it. But when you allow AWS, which is they are already experienced and have the right personnel, and you just focus on let's say your applications and data, it's much more better for you. And then there are others. This what is also referred as software as a service. Gmail is a very good example that is always brought up here. Like for example, your Gmail, you don't really bother whether it's running on which servers, where it is. You just use it.
It's too
It's
early,
very
not
easy. You just use it and you don't really bother what's. So software as a service is a very, very good example of Gmail is a very, very good example of a software as a service because it gives you that possibility to just use the service. And many companies go for such applications or such examples. So if you look here, I did go ahead to just discuss that. Um, we'll talk about what platform as a service is, and it helps you to deploy to infrastructure as service infrastructure automatically, operate the software, handle runbook scenarios automatically. We'll come to we'll come to these examples and we'll talk more about them, and you have a better understanding in case you're not so sure about it. If you are, there's a link I shared on AWS that just gives material that you can also read. But this is something that always, with time as we go, maybe after the terms start settling down into your mind and you start having a good understanding. But there's going to be a lot of new literature at the beginning. And you'll notice there's a lot of use of, when it comes to IT, for those who are completely new, a lot of abbreviations. So rather than writing software as a service, you see something like this, SaaS, we just talked about, and then they will actually read that as SaaS, this will be PaaS, and this will be IaaS. So you have to get used to seeing abbreviations like this coming up often. And yeah, this is an example. I'll leave this, you'll see that in the notes of what this pizza as a service is, just trying to tell you, to explain the different types of cloud computing using the example of pizza, right? So when you do traditional pizza, so pizza that you are making at home, which is the example of on-premises, you own everything from the cheese, the toppings, the tomato sauce, the pizza dough, the fire, the oven, the electric gas, drinks and dining table. That's pizza made at home. You do everything. But if you're going to do take and bake, which is infrastructure as a service, so when you are doing that, the cheese, the toppings, the tomato sauce, and the pizza dough, you don't have control over that, right? You just, like if you walk to a supermarket and you buy pizza that is already made, and you just need to go and maybe bake it, or put it in the oven. So what you bother after you buy it is just you have the fire, the oven, the electric gas, and then definitely some drinks and the dining table for the people that you are going to serve pizza with. So that's an analogy of infrastructure as a service. You just take home to bake. If you are using a pizza delivery service, so you order your pizza online, so you don't care, you just specify the sort of cheese and toppings and tomato sauce. You don't have control over all of this. The baking, the fire, you have completely no control. The only thing you bother about is the drinks and the dining table. So when the delivery man comes at the door and brings the pizza, maybe he will even bring some drinks along already. But you care of just the drinks and the dining table. So that's like how platform as service with cloud computing, you can think of it. And then if you are dining out, then that is more of software as a service, because everything the dining table is, it's not even yours. The drinks are also brought to you. So everything is managed by the vendor, the person delivering. So if you are sitting somewhere and eating pizza, so that would be an example of software as service, and we are giving Gmail as well as a good example. So this analogy maybe can help you try to have a good understanding of what these different, how you can start thinking of what these different types of cloud computing will look like if you were trying to figure out, if you're having a big difficulty. I see, France, you say the analogy is helpful. It makes you understand. Yeah. So try to look into this. And there's a video here that I want us to just watch briefly. It will help just to explain the hybrid model. And let me share this video, and let's just watch that and take a break a bit. I think it will bring some light. Okay. I think it starts at, you can watch all of this later, but I want us to watch that from the types of cloud computing model, so that it has a very good analogy of, okay. Okay.
The volume is a little bit.
Okoboji,
So,
yeah, I wanted to mention that the volume
sorry?
is low. I want to mention that the volume is low. Maybe you can stop and share again with the video. Share your video.
Okay. Yeah, let me increase
Deployment
that. I hope it's
models,
better
public, private,
Oh, yeah.
and hybrid cloud.
now. Okay.
Imagine you're traveling to work.
Okay.
You've got 3 options to choose from.
Okay, so this is talking about the different deployment models. We did talk about the public, the private, and the hybrid. So I just want you to watch this video. It has a good analogy of those different models, and I hope we'll
3
be able to
types of
understand.
deployment models, public, private, and hybrid cloud. Imagine you're traveling to work. You've got 3 options to choose from. 1. You have buses, which represent public clouds. In this case, the cloud infrastructure is available to the public over the internet. These are owned by cloud service providers. 2. Then you have the option of using your own car. This represents the private cloud. With the private cloud, the cloud infrastructure is exclusively operated by a single organization. This can be managed by the organization or a third party. And finally, you have the option to hail a cab. This represents the hybrid cloud. A hybrid cloud is a combination of the functionalities of both public and private clouds. Next, let's have a look at the service models. There are 3 major service models available: IaaS, PaaS, and SaaS. Compared to on-premise models, where you'll need to, this represents the hybrid cloud.
Just
The organization.
Just to stop here, you understand the public cloud here is given the analogy of using the bus to go to work because it's a shared, everyone, you are sharing that. That's where Azure, AWS, and Google Cloud come in. You are sharing that. Then the private cloud here can be looked about like your own private car that you are using. You can use that to go to work. Then the hybrid cloud here is a mixture of both worlds here, and it's a cap. So you can think of the hybrid cloud as taking, let's say, a taxi to work. You know, it gives you, it's definitely not yours, but it has some privacy into it. So that's how you can think of the different deployment models. The public cloud, either you can be looked upon like taking a bus to work. The private cloud could be owning your own car. And then the hybrid cloud, you can think of it as taking a cab. And let's see the example, how the analogy he uses for the different service models here.
Next, let's have a look at the service models. There are 3 major service models available: IaaS, PaaS, and SaaS. Compared to on-premise models, where you'll need to manage and maintain every component, including applications data, virtualization, and middleware, cloud computing service models are hassle-free. IaaS refers to infrastructure as a service. It is a cloud service model where users get access to basic computing infrastructure. They are commonly used by IT administrators. If your organization requires resources like storage or virtual machines, IaaS is the model for you. You only have to manage the data, runtime, middleware, applications, and the OS, while the rest is handled by the cloud providers. Next, we have PaaS. PaaS, or Platform as a Service, provides cloud platforms and runtime environments for developing, testing, and managing applications. This service model enables users to deploy applications without the need to acquire, manage, and maintain the related architecture. If your organization is in need of a platform for creating software applications, PaaS is the model for you. PaaS only requires you to handle the applications and the data. The rest of the components like runtime, middleware, operating systems, servers, storage, and others are handled by the cloud service providers. And finally, we have SaaS. SaaS, or Software as a Service, involves cloud services for hosting and managing your software applications. Software and hardware requirements are satisfied by the vendors, so you don't have to manage any of those aspects of the solution. If you'd rather not worry about the hassles of owning any IT equipment, the SaaS model would be the one to go with. With SaaS, the cloud service provider handles all components of the solution required by the organization. Time for a quiz now. In which of the following deployment models are you?
Okay, I'll allow you watch and complete that video later. It's on the slides, and then maybe take as well the quiz. Let's go. ahead and try to wrap the class and maybe have the opportunity to do some questions before we go. So yeah, those are examples of infrastructure as a service. You'll come to learn about Amazon EC2, platform as a service. You'll come to learn about that, Elastic Beanstalk, software as a service. Most Google apps fall under this. This was just to, you may not know what Amazon EC2 is at the moment, but that's absolutely okay. That's why you are here, and we'll help you know about that and even more and what it can do for you. Then Elastic Beanstalk also is another service that we'll talk about as we go with the lecture. Um, yeah, pricing of the cloud is pay for compute time, pay for data stored in the cloud, and data transfer in is free. Some of these components of these topics will also go deep into pricing and billing is a topic on its own, and it will be handled by one of our community leads, Lady T. So yeah, you definitely like when she presents that. So, Renee, I see you still have your hand up. Before I have some questions and answers, I thought that maybe, just to relax and let have a feel of how much you've been able to grasp, we can do that. But Renee, please come in now. I think I've covered what I could. Yeah.
All right. Good morning to everybody. I hope you can get me very well.
Absolutely.
All right. I have this worry that has been like, I have been thinking about it and trying to see if I can get answers. Now, if we are talking about cloud computing, and then we are talking about not having physical infrastructure to or to store our data, can I think of cloud, the cloud, to be something like a memory chip? And if that be the case, that is like yes, you say it's a virtual space. Now, what place host to this cloud? Because you cannot store your information in nowhere.
Absolutely.
Information has to be stored somewhere. So if you are storing your information in cloud, what place host to this cloud? And then the next question is like we were talking about the different service models, and we began with like something like on premises. Can I think that on premises falls within the domain of traditional IT?
Correct. That's very correct. On premises is actually when you have data, when you are running your own data center. Yeah.
Okay.
Mhm.
Thank you.
But then, right. So let me come back to your first question, which is actually the worry that everyone always have, because when we talk of, when you hear cloud, um, um, what comes to mind is people are looking outside to see if, yeah, looking into the sky, but actually the cloud starts from, there is physical infrastructure involved. I will highly recommend that. Okay, I will highly recommend. So because AWS is a network, right? AWS is a global network. I'm trying to have the video, the diagram. I always have for the link. I don't know where I keep that link that shows a representation of AWS global infrastructure. I hope I can have that. Yeah, right. That will give you a good overview. So, but without that, I'll still space to say that AWS is a global infrastructure network. It's a massive network that has data centers that is owned by a company called Amazon. So it's a huge network with data centers spread across around the world. And these data centers, it's just that they are much more advanced than what you had in traditional IT, and they have connected their huge network to the internet and are offering the services that you will have had in traditional IT over the internet. So the reason of the word cloud is because you cannot really, traditionally, the internet had always been, if you look into diagrams, the internet has always been represented by a cloud, by cloud icon, so to say, or an image. When you always see the internet, it's always been represented as cloud. So what you really call as cloud is actually, it's just that it's because you can't you can't go out there and say, when you deploy your infrastructure, you know it's deployed in a say. If you're deploying, say, in Europe, the region Europe, you may be able to choose your zone, but you can't go out there and say, you may know that it's deployed in Europe and maybe Frankfurt, the data centers are somewhere, but you can't really go out there and have them. So the cloud is actually, there's a global infrastructure, a very massive one. And what I was saying is to understand more, I'll advise that if someone is still having a problem, make sure that you visit our Slack channel. There are some two videos there about introduction to cloud. More actually, how does a data center work? We did watch this one about cloud computing, these two, but this video on the data center from Google will give you a very, very good example of how the data center works, and you start seeing how everything connects and what the cloud is all about. But think of AWS as a massive network it's a really massive network that they have, that you just need, that is offering what you could have had, what you could have maybe run on your own, but AWS have that and they're offering it for as a service. So basically, but we'll see more into that when we come to talk about AWS the different regions, and yeah, I think there's a map here, but it's not really what I want. I'll try to get that map ready in the one next service. I don't know why. I can find it. I was not expecting that. It just went off here. Before, yeah, Renee, I hope that helps, right?
Ban, I know with no really good IT background, it can be difficult to even conceptualize what you are saying, that it's a massive global network. But I know this doesn't really fit the context. But Renee, if you think of it like going to I don't know where you grew up, but I'll assume that Cameroon. If you think of going to a cyber cafe in Cameroon and you have your own computer, you go and sit somewhere and then there are computers connected, and then you take your own computer and you hook to it. You can use resources, right? You can access their internet and you can use their printer. You can use to do a lot of different things. Then if you think of all the cyber cafes in Cameroon, if they are all connected together, then you can actually sit in Boya and print something in Eboloa. So I mean, it's not exactly the case, but that's similar to how the global network is. So they're actually real computers, as you are thinking. They are real computers. They are situated somewhere and you can walk in and see them. It's just that AWS wouldn't let you go there.
Yeah. Thanks for that, Joachim. And just before we go ahead, Elsie, you have a question before we...
Yeah, I don't have a question. I don't know if you can go back to the slide that has infrastructure as a service versus platform as a service.
This one?
No, yes, this one. Yeah, so my question is, with someone like me who has little or no IT knowledge, when they're talking of the virtualization, OS, middleware, I really don't understand what it means by you managing this or AWS managing whatever AWS is managing it. So that's one of my questions. The second question is for SaaS, just like you use Gmail as an example that is relatable. I want to understand the characteristics Gmail has that makes it SaaS. And if you do have other examples for PaaS and IaaS that are relatable.
Yeah. For SaaS, I was saying, like for Gmail, you just use Gmail, right? Because you just send your email and you receive that, so you don't you don't bother about the infrastructure that's handling that, the network, the storage. You don't manage where your emails are stored, right? The servers where Gmail, the software is running, the virtualization. But as I did mention, I'll talk a lot about virtualization. So what will happen is you understand, like you have your normal computer, because that's at least I think the basic knowledge or understanding that everyone has now. You have your physical laptop, or at least you know what a computer is. And then we'll talk about the network storage. We'll define that. Then we'll bring in the concept of virtualization, of what it is. And then once we talk about that, then we'll talk about these different layers. So I will say just hold on for next class. I want to deal with these different components, then bring virtualization. Virtualization is actually what led to cloud computing, because virtualization, we're going to be talking about cloud computing. I'll explain all of that. And then these other parts as well, then you have a good understanding. With Gmail, like I'm saying, with Gmail, you don't bother about all of this, but to understand to be able to understand these components, I'll need to explain what this is, and then you see how Gmail fits. The other example I gave for IAS was EC2, but then we still have to learn what that is. Another example I gave here was Beanstalk, is for running web applications. We'll still have to talk about that as well. So I'll say be patient for next lecture. I did give those examples, but yeah, we'll talk about, and then most Google apps fall under that, like your Drive, Google Drive, if you use that, Google Documents, you just go in there and just use it. So we'll talk about these in much detail, and with time they will start making some sense. But I can imagine and understand maybe how difficult to comprehend, especially if you don't yet know what this even mean, or the examples. But that is why we are here, and will help you understand that, Elsie.
Thank you.
Yeah, you're welcome. Before we go, I think if in the worst case, I hope I've not shown you guys the answers, but let's try to take one or two questions. The other questions we'll share. Then you can have the slides, and then you'll be able to finish the other questions on your own and maybe see what they stand for. So let's start with the first question based on what we have done today. Dash is a global design principle which supports growth in users, traffic, or data size with no drop in performance. If you know the answer, you can either type it on chat or you can go ahead and say it. What will you say is it scalability, go serverless to reduce compute footage, design for failure, decouple your components? Dash is a cloud. Yeah, I see Bonfen, you say that's A. Who has a different view, or who wants to? Napo
I will go
says
for
it's A.
scalability.
Thank you,
I take scalability too.
Great. Definitely you guys are on track. Systems that are expected to grow over time need to be built on top of a scalable architecture. So that is a cloud design principle which supports growth in users, traffic, or data size with no drop. Let's try the next one. What cloud computing model deals with services such as EC2 instances? What would that be? IaaS, PaaS, DBS. Okay. You say A. That's
yes, A.
okay. Right.
Yeah.
Okay, Renee. Sorry. Yeah. Definitely. Fanny says A. So definitely you are getting those fundamentals right. Everyone have it. EC2 is an example of IaaS. If you are going home today as a takeaway, knowing that you've known EC2 is an example of infrastructure as a service, your fundamentals of cloud computing are really growing. So definitely, as I showed as I explained, infrastructure as a service contains the basic building blocks of cloud IT. This is not all we have seen about infrastructure as service, and this is not all we have seen about EC2. So for someone who have not yet understood, or even if you know that EC2 is an example of IIS, but you still don't know what EC2 is, or still not have a good understanding of what IIS is, please don't be worried. That is, as the classes go on, we'll be coming back to these terms and explaining them again. So have that. I already have the top of the hour. Let me take this last one just to see. You can finish the questions on your own. Which of the following is one of the benefits of migrating your system from an on-premises data center to AWS? Which of the following is a benefit? One of it is, A stands for enables the customer to eliminate high IT infrastructure costs since cloud computing is absolutely free. B says eliminates the need for the customer to implement client-side or server-side encryption for their data. C says enables the customer to focus on business activities rather than on the heavy lifting of racking, stacking, and powering servers. And D says completely eliminates the administrative overhead of patching the guest operating system for their EC2 instances. Which of those will be the answer?
C.
Great. I see so many people on chat also saying
C.
C. Right.
C.
Thank you
C
very
is good
much.
enough.
C is the correct answer.
Thank you very much. Let's leave that for now. And you finish the other 4 questions, and if you have worries, do find out why. But before we come next week, just some quick announcements. I know some of you, maybe you are completely new, but what I want to remind is if you did not watch the onboarding session on Saturday, yeah, thank you. Our community lead, she has posted that again on chat. I highly recommend that please do watch the onboarding session, so that, because I see so many people asking questions that have already been answered so many times. Unfortunately, we don't have that constant support, and I don't want someone to feel like maybe they asked a question and no one did answer. So please watch the onboarding session. Ensure that you are on the Slack channel, because there's a lot of information. And if you're on the Slack channel, please, once you watch this video, I want to see many likes. I think on the onboarding session, you did show you how to do that. Go and like this video once you watch it, so that I can see the count of the number of people that are there. And then if you are doing this course, you need to ensure that you are on the practitioner channel. I see, or we have 50 people here, but on the practitioner channel, I have just 33. All the recordings will be shared here. So if you happen to lose your phone and you have access to the practitioner channel, you will come and still have access to all the data and recordings. So make sure that you join the channel on Slack, and make sure that you are able to have access. As you see, the PDF files is here. And then, yeah, make sure that you also introduce yourself. We have about, and so many new people, there are about 69 have joined the self-introduction channel, but it's always good to know the people that we're working in, and then maybe if you, yeah, we just know who you are. It's a community, we are networking, so don't come and be in the community and be so isolated again. So make sure you just introduce yourself. We appreciate those who have done so. The notice board is where we post most of the information, especially on how we from cloud came about here and some frequently asked questions. Try to look at these questions, and yeah, they address some of the questions you already have. It will avoid the situation of you asking questions all the time. And make sure that you are on the Telegram. There are two different types of there are two main channels. The main channel, which is the WeFund Cloud channel, here we are discussing general activities related to cloud. You always see general information, but for the exam and the practitioner course, you have the practitioner channel. Make sure that you're on both channels, because here we'll post information about the practitioner, but then for the other one, the WeFund Cloud, the main forum is where we discuss everything that could not be related to practitioner as well. So make sure you belong to all the right channels, and make sure that you are using all of them. And then once you have a question, try to always go to Slack. You will have seen that it was already answered. Try to watch the videos. I repeat, the onboarding video, some of those questions are answered, and you won't find yourself asking the same questions all the time. And always scroll and read the chat, because something you are asking is already answered as well by someone at the top. and then you don't have to waiting for long to get an answer. So thank you very much. It's already 5 minutes. I don't always want to leave people after the hour. It's great having you, and do your assignments for next week, and then we'll meet and talk more about the cloud, and definitely, yeah, you come, you get to know more. So
Uncle Van,
let me
1 second, please. Can you help, or someone help post the name of the channels that we need to join? Because when you just join Slack, I think all those channels are not there. You need to search before you get the name. So if we can get the name of those basic channels we need to join, so we can search on and add ourselves to the channel.
Right. That is handled. Yeah, that's handled on the onboarding video. That's why I was emphasizing that everyone should watch that video. And then you has also posted the different links to those channels on chat now. Maybe you want to copy them, or you wanted to add something more on that, I think.
No, on something else. I mean, we sent a feedback poll yesterday, and please, when we appreciate when you take part in the survey with the feedback, so we should know what should we change, what works for you people. So please, when you see the poll, I mean the quiz, not the poll, the survey, please do answer. It helps us a lot.
Great. Great, thanks for that. So yeah, let's make it interactive. If someone can ask a question on chat and you already know the answer, don't just shy away and wait that maybe someone else from the community will do it. Please feel very free. If you know the answer, go ahead and answer. And if you see a poll, participate on it. Feedback is very important. And if there is someone that's interested to join our session, you please share the link to the form. You can send the link to the form for them to fill, because once they fill that form, we have all their information, and then it's much more easier to add them to the different channels. Don't send the number and for us to add, because it becomes really heavy work. But when they fill the form, then maybe at the end of the day, all of them can be added at the same time, and it's much more easier. Then they will all go into the different channels as well, right? Okay, let me stop the recording for this morning. And if there's something